Yes, yes.
The link is provided in the portal itself. So I think under the English video, you will find one link called the Hindi translated video of that particular lecture. So you can just go and check that out.
Yes, ma'am, you have taught there.
Yeah, for week one, I have done the recording, and for week two and three, Vishal sir had done so.
I have a doubt, regarding relations. I'm still not clear about symmetry and transitive, and the third one is your. What's the third one?
Reflexive.
Yeah, reflexive.
Yeah, okay, we can recall the relations too. So it's better if we try to solve some of the examples from activity and practice. And it will be much more clear. So I'll explain the definition again, but with that, we'll try to solve the questions too.
Okay.
Ma'am, I have a doubt in activity 1.7, question number 1.
Okay, so I'll go from the practice assignment to the top activity question or to the top activity 1.1. Okay, so when activity 1.7 comes, just remind me your doubt.
Okay, ma'am.
Okay, because if we randomly do, then it will take much more time and some of the question will left. So that's why I just go with the flow with particular order.
Yeah,
Ma'am,
absolutely.
I could not also understand the relations. So please briefly tell the relations, concept of relations.
Yeah, sure.
Thank you, ma'am.
So 36, 37 people are still joining. So just wait for 8:10, right? So we'll start at 8:10.
Ma'am, on to function also.
On to function. Yeah.
Yeah.
So what we can
Good
do, we can
evening,
just
ma'am.
recall. Yes, very good evening. Who's this?
I am Saravanan.
Yeah. Yes, Arun.
Ma'am, I'm not able to see the screen. Is there any way can I
Yeah,
see
I
this?
haven't shared. Now I can share. Now my screen is visible, right?
Yes, ma'am.
Okay, so let's start with recalling the relations. Okay, so what is a relation? So before that, you guys are familiar with Cartesian product. So Cartesian product means nothing. That means if we have a set A and another set B, then for these two sets, we can actually define a product set that is named to be Cartesian product of these two sets. And it's again a set. So that means A cross B is the notation for Cartesian product of A and B. And in this set, we contain all the ordered pair of A comma B. Right, so we'll contain these such type of pairs where the first element belong from the first set A, the second element belong from the second set B. So that means here A belongs to A and B belongs to B. This will be a set comprehension notation for Cartesian product. And here it is not necessary that you should have to, you have to take two sets. You can take Cartesian product of three sets, four sets, or even the infinitely many sets also you can take. Okay, so that thing you can learn if you go to some of the higher mathematics course. But it's that means we have the choice that we can take two sets, three sets, four sets, or whatever number you want to take in the Cartesian product. Okay, so what is a relation? So in mathematics, relation is nothing but a subset of any Cartesian product. Okay, so relation is a subset of Cartesian product A cross B. Okay, so you can say that any relation is nothing but a subset of some Cartesian product. Here also, it's not necessary that you have to take A cross B, that means two sets. You can either take, you can also take the same sets up to any number of time. Okay, and you can also take the different sets up to any number of time. Okay, so any subset of these Cartesian product is known to be relation to us. Now we have defined several types of relation, and these relation will have their own definitions. Okay, so let's recall quickly with the reflexive relation. So what is okay, so what is reflexive relation? So suppose we have a relation on a Cartesian product A cross B. So in general, I mean, uh, up to 90% cases, reflexive relation is defined for the same set. That means A cross A. Okay, so there will be some cases where relation is defined for two different type of set when we want to talk about reflexive relation. Okay, so suppose we have a relation over the Cartesian product A cross B. So that means R is nothing but a subset of A cross B. Then we say that this will be a reflexive relation if this statement is true. Now what is the statement? That if for all A belongs to A, the reflexive pair. So what are the reflexive pair means? A comma A type of pair. So if for all A belongs to A comma A type of pair belongs to R, then we say R is reflexive. And here the condition is, two conditions are there. First thing is that for all A belongs to A, this condition should be true. Okay, that A comma A belongs to R. So that means every element of A should be related to itself. That's also we can say about this particular term, that A comma A belongs to R means A should be related to itself. So such type of relation are known to be reflexive relation. Okay. Now is there
Excuse
any
me,
doubt
ma'am.
in this? Yeah.
Yes, ma'am. Ma'am, suppose a set A is equals to 1, 2, 3, 4. Ma'am, can you
Okay.
please
A is equals to
1, 2,
1, 2,
3, and
3.
4?
Okay.
And there's ma'am relation R equals to 1, 1.
Just 1 second. Yeah. So 1, 2, 3, 4.
Yes,
And R
ma'am.
is equals to
1, 1,
1, 1,
2, 2,
2, 2,
and 4, 4.
4, 4.
Ma'am, can we consider this as a reflexive relation or this is an identical relation?
See, identity relation is reflexive, but this is not neither an identity relation nor a reflexive relation. Why is this so? Because for this set, the identity relation will be the same pair. So that means 1, 1 should be there, 2, 2 should be there, 3, 3 should be there, and 4, 4 should be there. And no other type of pair should be there. So that means such type of pairs only, such type of pair should be there. That means every element should be related to itself only. So such type of relation are known to be identity relation. So for this set, identity relation will be this. And this is not reflexive because it is not satisfying this particular condition for all. Right? So there is an element 3 which is not related to itself in this relation. So that means here, 3 comma 3 is missing.
Okay, ma'am.
Right? So that's why this is not a reflexive relation.
Okay.
So
Ma'am,
you're
so
saying
for
that every
identity
element,
relation and
every
reflexive
element of A.
relation, both
Just
of
one by one.
each and every element in the set should have similar pairs.
Yeah. But such type of, reflexive relation can have other pairs too, but the identity relation cannot. That's why we
Cannot,
say that
yes.
every identity is reflexive, but the converse is not true.
Okay,
Okay.
ma'am.
Does that mean if we are missing any pair, it will not be
Huh.
identity?
Yeah, it will not be identity as well as it won't be reflexive.
Okay.
Okay, now let's go to, yeah.
Identity is a subset of reflexive relation, right?
We cannot use the term subset because here they are not sets, right? They are type of relations. So we can say that every identity relation will have reflexivity property inherent in it. So that means identity relation is reflexive, but not every reflexive relation is an identity relation. Okay, so that's what you can say.
But every identity is a reflexive relation, right?
Right, right. Huh. The second type of relation is symmetric relation. So see, these are all properties of
Reflexive,
relation. So
ma'am,
that
how every reflexive cannot be identity?
see, we have seen the examples, right? So where suppose in this example, I'll consider the R to be equal to. Suppose I'll take all the identity pairs, so all the reflexive pairs. So that means these 4 pairs. And I'll take any one of them. So that means 1 comma 2 I'll also take. Now this is reflexive because this condition is true that if for all E belongs to A comma A is there. Some extra pairs are there, but still A comma A is there, right? So that's why it will be reflexive, but it's not an identity relation. Is that okay? So I hope it will be okay because this is third time we are discussing this relation. Okay, so now let's go to symmetric one. So symmetric relation means, so again, suppose I have a relation over A cross B. Then this relation is said to be symmetric if we have any type of pair. So if we have any pair A comma B belongs to R, then it's symmetric pair. So what will be its symmetric pair? B comma A. So if A comma B belongs to R, then B comma A should be belongs to R. So if we have such type of relation, then it's known to be a symmetric relation. Okay, so it means if A comma B is there, then B comma A should be there. So such type of relation are known to be symmetric relation. Okay, so now there is one remark here is the identity relation is symmetric relation. So if you consider identity relation 1 1 2 2 and so on 4 4, now here what is happening for all pairs A comma B is there and B comma A is also there, because for 1 comma 1 if you consider it symmetric pair, that will be again 1 comma, it's there in identity. So for all pair we have a symmetric pair, so that's why it will be a symmetric relation.
Ma'am, identity only have one.
Yeah, so identity have 1 1, but 1 1 symmetric pair is 1 1 only. So that means this work for I mean its
So ma'am,
symmetric
if
pair
there
is
is
itself.
if there is 2 it cannot be identity.
Means
Like if in a set there is 1 1 2 2, can it be identity?
see, identity relation means all identical pairs should be there. Here I have written dot dot means all pairs are there. 2 2 is there, 3 comma 3 is also there.
So this is
Okay.
identity.
Yeah, this is identity relation, but it's also a symmetric relation too, because satisfy the definition of symmetry, right? Is that
Okay,
fine?
ma'am. Okay.
Okay. Now the next relation is transitive relation. The deadline for submitting assignment is 22 of 11.59, if I'm not wrong, right?
Yes,
So
ma'am.
transitive.
To
Yeah.
11.
So transitive relation means if it satisfies this condition, that if A comma B is there and B comma C is there in the relation, then the transitive pair A comma C should be there. Okay, so such type of relation are known to be a transitive relation. So but what happened for transitivity, we can check it in two ways. So for the first way is if there is no such kind of pair. So if there is no A comma B and B comma C. So that means here there is some special thing about these two pairs. They are connected by one transitive element, which is B. Okay, so if you don't find any such kind of pair A comma B and B comma C, then you can vacuously or trivially say that that relation will be a transitive relation. Okay, so if there is not, if there is no such pairs, then we can say yes, it is a transitive relation. Okay, and this is because since there is nothing to claim that our statement is false, right? So whenever we don't have something to say that this thing is wrong, we already assume that okay, it is already right. So the same thing happen here. So if you don't find any transitive pair A comma B and B comma C, then trivially or vacuously you can easily say that okay, this relation we can assume that it is a transitive relation. Okay, and the second part is if you find any pair A comma B and B comma C, if A comma B and B comma C are there in R, then you have to check one condition, and then that condition is nothing but you have to check that A comma C belongs to R. Okay, so if it is true, then you can say yes, it is transitive, and if it is false, then it is not transitive relation. Okay. Okay, so I hope that is these things are clear. Any doubt? Anything which you are not able to understand?
You might in transitive, that part is still not clear, which where you were talking about, A is related to B and B is related to C. That part, still not
Means
clear.
what?
The mid
See,
part which we talked about.
the first one or second one?
This is the first one.
So see
In the
what
first one,
happened.
ma'am.
See in the first one what happened if suppose in general also suppose we have something to check, right? We have some rule to check, okay, if this person passes this particular test, Or else what we can say that for transitivity, either we need something which contradict this definition, or which says that okay, this is not possible type of thing. Okay, so but this statement contains two part. First is if part. So if condition is not there, then there is nothing to check, right? So vacuously or trivially we can say that if we are not able to find such pair, then we can easily say okay, it is transitive, it passed the transitive test, something like this. So for
What does
example,
it mean by
identity relation.
what
Yeah.
does it mean by aquously and transversely?
See, vacuously means there is nothing to prove this statement is false, right? There is nothing to say, and there is no proof based on which we can say that the statement is false. Okay, so that means for saying something is wrong, we need something, some proof we need, some evidences we need, right? So here we don't have anything which will say that this particular thing is not happening or this is wrong or type of something, right? So here the same thing is happening. So if we don't have any proof or any evidences, we easily assume that okay, it should be true, it will be true, right? Something like this. So that means there is nothing to claim that this condition is false. That's why we are saying that okay, it is true, it
So
passes the
this is the meaning
transitivity
of
test.
aquously. What does it mean of travesly? What did you said? Travesly.
Trivially also, trivially means naturally type of thing. Okay,
Okay, so ma'am,
naturally.
can you please just help us with one more example where we do not find such condition?
Yeah, see, identity relation just contain that condition. So for example, we have identity relation 2 comma 2 is there, 3 comma 3 is there, and 4 comma 4. Here you cannot find such type of pair a comma b and b comma c,
Yeah,
right?
that's right.
So that means in this relation, since there are no such kind of pair, we can trivially or we can vacuously say that this is a transitive relation,
Okay,
because
so
there
an
is
I.
nothing to
Mhm.
fail our test, right?
Okay. So an identity is a transitive symmetry as well as your
Yeah,
Reflexive.
yeah,
reflexive
reflexive.
relation.
Ma'am, could you give an example for the second condition too?
So see, second condition also what I can do, I can just put two pairs here. So suppose I'll take 5 comma 4 is there, and 4 comma 3 is there, and 5 comma 3 is there. Okay, so suppose I'll take another relation R which contains such type of pairs. So here what is happening, 5 comma 4 is there and 4 comma 3 is there. So this is the value of A, this is our B, and this particular pair has B in its first place, right? So A B and B C we have. So now we have such type of pair. So here we have to check that this A comma C, which is 5 comma 3 is there or not. But 5 comma C is 5 comma 3 is there. So that's why it's a transitive relation.
Out in
Please
this.
mute yourself. Sorry. Okay. So such kind of relation are transitive relation.
Madam,
Ma'am,
I
identity
note
But
relation
here,
is
here
also
madam.
called.
also we need 5 comma 4.
Madam, I
Sorry.
have one clarification here.
Yeah.
Now, if you take this 4 comma 3 and 5 comma 4 in opposite manner, like from 4 it
Yeah,
goes
but
to
here,
3.
either here other transitive pairs also there. So that means 4 comma 4 is there, but 5 comma 4 is there, 4 comma 4 is there. So we need to check 5 comma 4 is there or not. But 5 comma 4 is not there, so that's why it's not a transitive relation. Right. So we need to check the transitivity condition for every pair, every possible pair A comma B and B comma C.
So, okay. 4
Yeah.
to
So I
3.
haven't.
Okay, madam. Okay. So all pairs
Okay.
we have to check. That's what I was telling.
Yeah. For all pairs, you have to check. For all pairs,
So,
you have to check all these conditions in every relation.
so the example what we have just discussed, this is not transitive relation.
Yeah, it is not transitive, not
Yeah.
transitive.
Okay. Since you
I want to
written this
make
is
it
transitive.
transitive, but now it is not transitive. Okay. So I hope these things are clear now. I'll just go to practice assignment.
Ma'am, reflexive and identity relation are same, no?
No, there is one little difference that in reflexive relation we can have some other pairs too, except the identical pairs.
Okay, okay. Like 1, 1, 2, 2, 3, 4, 3 can
Yeah.
be there in reflexive, but identity pair you have to remove 4, 3.
Correct.
It should be 1, 1, 2, 3, 3 like.
Okay, so my screen is visible, right? So this is the practice assignment 1, week 1. So I'll cover your doubt. So from practice assignment, whatever in which questions you guys have doubt, just mention in the chat box. I'll go one by one. Okay. So I won't solve each and every question because that's not the point of doubt session, right? So we have to discuss your doubts. So whatever thoughts you have, so first I'll hear that and then I'll try to explain. Okay. So from this particular assignment, if you have any doubt in any question, you can just mention the question number and we can discuss in detail. And I think you guys are comfortable with this method, right?
And the last question.
Question. Don't mention then each and every question. Okay. So there is question number 1. So yeah. So in this question, so given below is a Venn diagram for a set of students who taken maths, physics, statistics. Okay, so which of the following options are correct? Okay, so this is Venn diagram is given to you, and now you have to judge something. So it says that D is the set of students who taken both maths and statistics. Okay, so first just notice where this D belongs. Okay, so this D is written in this particular section, right? So there are this type of Venn diagram, and here this portion is our D, right? So D is kind of intersection of A and B, right? So you can suppose I just have two circles A and B, then D is nothing but the intersection of these two sets. So that means here D is nothing but A intersection B. Now let's say A represent to which thing? So here A represents A is not there, this maths is there. Okay, maths and physics is there. So this circle actually denote the mathematics part. This circle denote the physics part. So that means this D is nothing but maths intersection with physics. It means D is nothing but maths intersection with physics. So D
But
is a
D
set of
and G are
students.
there now, madam, in the intersection.
G is also there, but G is kind of subset of D2. So that means G is just this little portion. This is our G. Okay, so
Yeah.
G is actually maths intersection, physics intersection, statistics. But D, for D, we can say that it's nothing but only maths intersection, physics.
How you have told that, madam? Because I felt that it is A intersection B minus A intersection B intersection C. That is what is D.
Okay, so you are okay. So you are saying that D is just this portion,
Yeah.
not the G one.
No, that is what I'm
Uh,
thinking. Maybe I don't know whether I'm right or wrong. You can explain me.
Actually, that could be true since these are written in this way. But in general, when we okay, so see. Uh, So if D is that portion, then that means suppose D is this particular portion. Then what is this? So it says that from maths intersection physics, we have to remove this particular part. Okay, so that means from maths intersection physics, if you remove the statistic part, then that will be your answer. So it's actually depend on the yeah. So it could possible that D is just only this portion because they have written in this way. Let me see. I'll just check the answer. The answer will tell us what is D there. Okay, so yeah, you guys are correct. So that means they are assuming D to be is nothing but just that particular portion. Okay, so that means D is just this small little portion. I thought D is intersection. Thank you. Okay, so here that means D is nothing but A intersection B minus of statistic part, the small little one. So D is maths intersection with physics and minus of statistics. That's clear, right? Why we have to minus statistics? Because D does not contain this G part. Yeah, thank you, Narendran, right?
Thanks, ma'am.
Okay, fine. So that means that's why this option is wrong then. Right? It's not correct. Now let's go to the next option, which says that D union E union F union G is a set of all students who taken at least 2 subjects. Okay, so let's see what is this set. So here it says that D union with E, union with F, and then
Yes,
union
ma'am,
with G.
that's correct.
Yeah, so that means maths intersection,
true.
physics intersection stats. So the set of all students who taken at least 2 subjects. So yeah, that's also correct, because see, E is the part where the students have taken only physics and statistics. So at least 2 is correct. So this is a correct option. Now E is a subset of the students who have not taken maths. And that's correct, because E is nothing but physics intersection with statistics. And these student does not have taken maths. Are there any students? Yeah. So that means this option is also correct.
Also
Let me know if I have any doubt in this question. Okay. So maths minus D is the set of all students who have taken only maths. Okay. So if you no, now that's not correct, right? Because if you find the region maths minus D, then this is our region. And here we are covering some of the part which have taken physics too and which have taken statistic too. So that's why this option is wrong. And then physics minus D union G union E is a set of students who have taken only physics. Okay, so that means D union, that means D union G union E as the set of, and physics minus is a set of students who have taken physics only. Correct, because if you remove this particular part, then we left with this particular part, and this particular part represent the student taken only physics. So that's why these 3 options are correct. Okay, fine. I hope
Hello,
this question
ma'am.
is clear. Yeah.
Ma'am, I have doubt in activity 2.5.
Yeah, we'll go to activity 2 one by one. Okay, first I'll cover this particular practice assignment and then go upward. Okay, so the
Ma'am,
next question is question number 9. Yes.
if we have doubt in any other question, matlab, else than assignment
Yeah,
and
we can discuss that at the end. That's also fine.
at the end, ma'am.
Yeah, because then I left these doubts, right, from the activity and practice.
Okay.
So, okay, so this is a question. So from the domain and the range, find the domain and the range of the following real valued function. Okay, so here what is happening? So I'll just explain the basic concept, how you guys tackle the concept of domain. Okay, how to find the domain of a function. Okay, so whenever someone asks you to find the domain of function, what you have to do? You have to collect all those real numbers for which your expression is well defined, right? So that means collect all those numbers or points, whatever you want to say, you can say. So collect all those points or all those number for which the expression is well defined. Okay, if the expression is given to you, if the graph is given to you, then that's a different thing. But in general, whenever graph is given, they won't ask you about the domain. Okay, so what you have to do, you have to collect all those points for which your expression is well defined. Now what is the meaning of well defined here is, well defined means 2 sense. First thing is, it should not be a complex number, right? You guys are familiar with complex numbers, right? Under the root of -1 type of number, it should not be a complex number. And the second thing is, it should make sense. Okay, so make sense means it should not go to plus infinity or minus infinity type of situation, right? It should not create plus infinity or minus infinity type of situations to us. So whenever a domain you have to find, you have to take care of this thing only, that you have to find all those real number for which first thing is, it should make sense. I mean well defined. So well defined means it should make sense. That means plus infinity minus infinity should not there. And the second thing is, it should not become a complex number. So that means under the root of -1 type of thing should not be there. So in this question, what is happening? So f of x is equals to under the root of 3 minus x is there. And we know that whenever this quantity will become negative, it will give us a complex number. That means under the root of -1 will be there. So what we want? We want 3 minus x should be greater than equal to 0. So that means x is less than or equal to 3. Correct. So this is our condition. This is the condition we are getting. So that means the domain of the, yeah.
Ma'am, can you explain again why we did greater than equals to 0?
Because see, under the root of minus quantity, suppose -5 I'll take, this is not a real number, right?
Yes.
Because we cannot find a real number whose square root is -5. So that's why. So that's why I'm saying that for well-defined means two cases should be there. One thing is you should not get a complex number. This thing you can write it as a 5 iota, right? If you are familiar with complex number, right? So this is a complex number to us.
Can we say that radicand should be always positive, and that's the reason why we take this?
Which thing should be always positive?
The radicand.
Radicand means this under the root portion.
Yes, ma'am. Yes.
Yeah, that's the thing, because under the root function is defined only when this under the root, the root expression is greater than or equal to 0. That's why this condition we get for domain. And for range, since it's an under the root function and over the positive quantity is there, so we know that f of x is greater than or equal to 0 for all x, right? Because we can make
ma'am.
yeah. So because under the root cannot be negative, right? The root of any function cannot be negative, because if you compute the under the root of 4, that will also equal to 2. So that's the general convention. Since here plus is there, so that's okay. So I hope this question is clear.
Yeah, what
Any
will be the
doubt in this one?
codomain?
My range
So
greater than
codomain will be x is greater than or equal to 0. All positive numbers. Wait, not x. So here we don't have we have x minus 3 minus x is there.
It will be less
So,
than equal to 0
huh.
and 3, I guess.
So that means under the root of 3 minus x should be there. So that means x is starting from 3, right? So that means x should be less than or equal to 3.
Yes.
So what we can say, we can take any, but we have to start with 3. So that means, yeah, it's greater than or equal to 0 only. Because if you put x is equals to 3, f of 3 will be under the root of 3 minus 3, which is equal to 0. And if you take any bigger number than 3, then we will get all the values. So it's 0 to infinity only. So that's why the answer will be this one.
Range will be 0 to infinity.
Greater than or equal to 0.
And domain will contain 0. Under root 0 makes sense.
Because 3 minus x is there. Not, see, expression is different. 3 minus x is there, na? That's why.
Excuse me, ma'am.
Ma'am, you pick out the fourth option, I guess. The second one.
X cannot be less than 0.
No, third one.
Range is greater than or equal to 0 and x is less than or equal to 0. That's the thing we have. The third one. I may have ticked this one, but yeah, the answer is third one.
Ma'am, could you please explain that how you found that range thing once again, please?
See, this function.
Ma'am, can you tell what is which is best way to find range?
See, for range, finding the range is not that easy always. So since we know only fundamental concepts here, so I'll just tell one thing is intuition, that observe the function. This is the under the root function, right? So we know that if you know the basic nature of under the root function, this is under the root x of graph, x is graph, right? Are you guys okay with this? So so what happened, whenever we have root function, it will take always the positive values, because under the root of, if you compute the root of any function, it will become positive anyway. So the first thing is observe the graph of root x. So this graph says that, okay, if we have any root function, it will always give us a positive value. But here the expression is a bit changed, which is 3 minus x. So that's why first we observe the domain point. So the domain point says that x should be greater than or equal to, x should be less than or equal to 3. Right? So I just put x is equals to 3. So when I put x is equals to 3, I get f of x to be equal to 0. So that means this function also starts with here. Right? And then as you decrease the value of x, so that means you'll just take x is equals to 2. So you'll get f of x is equals to under the root of 3 minus of 2, which will be equal to under the root of 1. Right? Under the root of 1 is again a positive quantity. So the function will grow. So ultimately the graph of function will also look some kind of similar to something like this, or it will just get shifted type of thing. So ultimately what I want to say, there is no general formula to find out the range. So one thing is just observe the expression.
Ma'am, but there is one formula where you can assume it y is equal to under root of 3 minus x, then y square minus 3, like that. Yes, through that
then
please.
this is No. This is in general not true. Why? Because see, here you are doing square, but this, if you do the square of this function y is equals to minus under the root of 3 minus x, I'll get the same expression, right? So if
Okay,
you
okay.
come, so that's the
Because
thing.
it will
So
be plus minus. It will be plus minus that. Why? Yes.
right now, if you take under the root, you have two ways to go. You can take plus root or minus root. So we don't
Okay.
know which. So that's why. So although 3 minus y square, here also if you find this will be a parabola, it will be a downward parabola. But it's not always the case, since it's not a bijective type of function. So what you are saying, that's true, but that approach is only true for bijective functions, because
So, ma'am,
if
okay.
so if you have bijective function, then what you can do, just find out the inverse of that function. If you are familiar with inverse, find out the inverse of that function and find the domain of that inverse. That is a one approach, but that works only for bijective function.
So
For that we need,
that's how you were doing it. Right now, no? Y square is equal to the bijective ways through the
but
inverse
that's,
function that you were doing. That's
but
how you were doing it, na?
not, it is not a bijective function. That's why I'm telling that
Yeah. But that is the way, na,
this,
to do it inversely.
that is a
The
one
way is
way.
that, na? Yeah.
That is a
But that's
one
for
way you can
bijective
do.
only. But it's not
Hmm.
bijective. That's why we are not doing through that way.
Right. There is one very, legit way is to find out the limit of function. Okay, since you guys are not familiar with limit, so what we do for range, this is a major thing what we have done. We'll just find limit x goes to infinity, and we'll find limit x goes to minus infinity. These two limits actually tell us about the x goes to minus infinity or whatever domain point you have. Okay, whatever domain point you have, these limits actually tell us about the range of function. And if you are, since we are not comfortable, we don't have gone through the concept of limits, so what you do, we just go via the graph. Okay, so
So
what you have to do,
first,
yeah,
so firstly, we have to find the domain, and through domain also we can find it like the way you did before. Through
yeah,
domain,
that's also
putting the
through
value
domain
of
also.
yeah.
Putting the value and then guessing the value where the values are growing. So here what happened, as I put x is equals to 3, I'll get f of x is equals to 0. As I put x is equals to 2, I'll get f of x is equals to 1. Not 1, under the root of 1, correct. 3 minus 2 will be 1. So that means here, since when I am decreasing the values of x, the function value is growing, right? So f of at x is equals to 3, f of x is 0. At x is equals to 2, f of x is 1. If you put x is equals to 1, then f of x will be equal to under the root of 2, which is slightly larger than 1, right? So from this also you can assume that, okay, in between values are also function can take. So such type of guessing you have to do.
But
Although
ma'am, this
if you are,
is not the legit way because
this is
it's
not the legit way.
because ma'am we have to like hit and try a lot because in the range it is saying it has to be more than zero. Okay,
Correct.
more than zero, root two can be that, but there are
Yeah.
certain kind of numbers between zero and one.
But
We
that
cannot
can
see
be
out
approached,
that.
right? Yeah, since you guys are not comfortable with, continuity limit, so I cannot explain that thing, why it will take all the values
Can you
between
do
0
that,
and 1.
ma'am, if it is possible? Right now, like if people can get it, they can get it. But if they can get it through that, if the people
No,
can get it
actually,
through that,
see what happened. If you find the limit of this function, na, then you'll get the answer. But you guys can go through graph too, na. So just draw the graph of this function. So it's not a difficult function to draw a graph. So either you can use Desmos, that will be fine. Since it's a practice assignment question, you can use Desmos, right? We assume that you will use Desmos. But if you are not using Desmos too, then also you
what
can
is it,
easily draw such
Desmos?
type of function.
No, what
Desmos
is
is a
Desmos?
graphing calculator.
It's
So
a
see,
graphing
Graphing
calculator
calculator on available.
on Google.
that's also
You
you
type
can use.
Desmos.
Madam?
Yeah.
Okay. So you're continuing. No. Once you finish, I just want to ask now.
Hmm. So see, you can use, but see, it's not always a good thing to use Desmos. You have to learn how this Desmos is actually drawing the graph. Okay. So one thing is pretty clear, that you should know the basic graph. Basic graph means you should know the graph of under the root of x, right? So if you have function, uh, Okay, so if you have function under the root of x, this will be the graph of under the root of x. Okay, so now here observe the changes when I change under the root to minus under the root 2. Okay, so if you do minus under the root 2, it just got reflected over the y-axis. So that means before minus sign, it was this graph. This graph you should know because it's a very basic graph, under the root of x graph. Okay, now you remember this graph. Okay, so whenever you change the sign of x of any graph, it will just got reflected over the y-axis. So this is a graph of under the root of my x. If you do minus, then it will get reflected over the y-axis. So here if you put a mirror over the y-axis, you will get that this graph is nothing but the mirror image of above. Okay.
मैम उस फंक्शन का जो LHL है वो तो माइनस इन्फिनिटी को अप्रोच कर, मतलब अगर हम लिमिट से फाइंड करें तो
नहीं, बिकॉज x गोज टू माइनस इन्फिनिटी पे ये इन्फिनिटी पे जाएगा, और x गोज टू इन्फिनिटी तो हम कर ही नहीं सकते बिकॉज डोमेन ही हमारा जीरो है, तो उस कंडीशन में हमें x गोज टू जीरो करना पड़ेगा. हाँ, so हाँ, तो वो चीज भी आती है. Okay, so here observe that when we change the sign, it just got reflected over the y-axis. And here, if you add any constant in x, it will just got shifted a bit. Okay, so if I add 3 here, see, observe that it just got shifted 3 units toward the right hand side. So this much shifting and scaling, you should know about the graph. So what happen if we add a constant? What happen if you multiply a minus sign, right? So from here, we can easily get the range of a function. So what is happening here, as the value of x is growing toward minus infinity, the value of y is also growing. It is growing with a very lesser rate, but still it's growing. So as I'll zoom out, it will approach to infinity at some point. So that means every value of y, every positive value of y is taken by this function. Okay, so that's how by the graph you can judge the range. So here you observe that any negative values of y is not taken by the function. If I put any negative value, suppose I'll take y is equals to 5, y is equals to minus 5, then this value is not taken by the function, because if it is taken, then these two lines should be intersect, right? These two graphs should be intersect. So by the graph, you can find the range. So what happens if you have a graph, then observe that is this graph is growing toward infinity or growing toward minus infinity, and which values of y is not taken by the function. So ultimately by the graph, for judging the range, you have to find which values of y are taken by the function.
Madam?
Yeah.
Now, since you are in the graph, now can you tell what is the codomain, madam?
Yeah, so here codomain is actually depend person to person. So for example, I can take codomain of this function to be real number. Someone can take codomain to be codomain of this function to be complex number, or someone can take codomain of this function. Yeah, so we have to take codomain larger from the range set. So I can take real number or complex number. So codomain actually depend vary person to person.
Okay, so then this function is not surjective, madam.
So it's also depend on the codomain. So for example, if I take codomain to be the all real numbers, then obviously it won't be surjective because the range is not equal to codomain, right? What is the range? Range is x greater than or equal to 0. And I am taking codomain to be real number. So in this case, it won't be surjective. But what happen if I take codomain equal to the range set? Then it will be surjective. You're getting
So
my point?
whenever somebody is asking about subjective and other thing, especially subjective, so they have to specify what is the codomain. So
What is the codomain is?
explicitly it has to be given.
Correct. And if it is not given, you will always assume that the codomain is the whole real number set.
Real, yes. Okay. Thank you very much, madam.
Okay. Is it
Ma'am,
clear?
yes. If we don't want to do it through graph, though, and we have to do
Then
it
the
like
best way is via the limit.
y is equal to under root of 3 minus x, we have to square it. So you were saying that there will be minus n plus both case of under root of x square minus 3. So can we subtract the minus under root of x square minus 3 so that we can have, is there any method or something like that?
For this one, suppose y square is equals to 3 minus x is there. I'll just take x is equals to 3 minus of y square. Right. So how could you proceed now? So you will find out all values of y for which this expression is valid, right? That's your approach.
Yes.
But for that thing, this is this particular expression is valid for all values of y. Right?
Okay.
I can put any value and I'll get the legitimate real number. Right?
Okay, so here this is the flaw. It comes from here.
That's why, because since it's not a bijective function, that's why. If you have any rational function with linear coefficient, that means suppose if you have any function of this point, this type ax plus b upon cx plus d. So for this type of function, you can use that method.
Okay.
Because these type of function are in generally bijective. So you can use that method. In general, mostly they are bijective, 97 to 98%. Hardly there will be one, or that also, mostly it will be bijective. So for such type of function, you can use this method that just
But we
change the
cannot do
value of
it.
x and y.
But we cannot do it when the coefficient of the x is more than one, or it's not integer, or what?
No, we can do it for anything. So suppose y is equals to ax plus b upon cx plus d is there. Such type of function is there where a, b, c, d are real number. Any real number you can take. So for finding out the range of such function, what you will do, this express x in terms of y, right? And find the domain of this function. But
Okay,
there
and
are
we cannot do like that when the coefficient of the x is like in a fraction and in a degree form, like 2, 3, 4 in
no,
in
you
this.
can do it. Real number means any form, anything you can do it. But in this way you cannot. That means here, see, it's a different kind of function than this one.
So when the degree of the function is not fraction, na? That's what you were saying earlier.
Yeah, fraction. Okay, means this x to the power 1 by 2 type of thing.
Yeah, 1
Yeah.
by 2 or 3 by 2.
1
Or
by 2,
if
3 by
the
2, or anything except 1.
okay, except 1.
Hmm.
It should be 1 only, then we can only do. Okay.
Ma'am,
Okay, so yeah.
hello. Ma'am,
Yes.
when x is negative, ma'am, please scroll down it. The previous question. Yes, ma'am. And when x is negative means less than or equal to 0, then also root 3 minus x will be positive. Then
Yeah,
we
because
can
of this minus sign. Because minus minus will become plus, so 3 plus of something will be positive, right?
yes, ma'am. So we can say that range will be x with
No,
the
range means what are the values of function is taken, right? What values are taken by function, not what values of x we can substitute. That will be domain. So domain means what values of x we can substitute in this particular expression. But the range means what are the values we are getting from that expression. Is that clear? What are the
yes,
values we are getting from that?
yes, ma'am.
Okay. That will be our range. Okay, so question number
Ma'am,
11, find the domain. Yeah.
ma'am, can I ask a question? Ma'am, there is a function in which we need to prove that it is onto. Ma'am, the function is simple. It says that it is defined from n to n, and f of n is n plus 1 by 2.
N to n, natural number to natural number.
Yes, ma'am. And the function is given like this: f of n is equal to n plus 1 by 2, n plus 1 by 2, when n is odd.
Okay.
And
when n is
n by
even?
2, yes, ma'am.
When
This
n
is
is
this is
even.
the well-known function, ma'am. I know that this is onto function, but how to show it mathematically, like?
So see, this thing you can show. See, what will be value of f of 1? F of 1 will be 1 plus 1 by 2. That means 1.
Yes, ma'am.
Right? So f of 1 is 1. If you compute f of 3, so f of 3 will be 3 plus 1 by 2. That will be equal to 2.
Yes,
Correct?
ma'am.
F of 5, that will be equal to 5 plus 1 by 2, 6 by 2,
5
that will
plus
be 3. So that means for
3.
every
How n
odd
plus
value, you are getting the natural number set 1, 2, 3, 4, and so on. And here n is not defined for 0. They should have seen that what will be f of 0, but it's okay. So that means for every odd number, you are getting your natural numbers back, right? 1, 2, 3, and for f of 7, you will get 4. So ultimately from this one, you can say that, okay, since we are getting all the natural numbers, we are the range will be the set of natural numbers.
Ma'am, how a function of 1 is 1 plus 1 upon 2? There is minus sign, na? Minus n plus 1 upon 2.
That is not minus. That is the
That is sorry,
bracket.
this is
Okay.
Ma'am, until and unless if they in the question it is not said to take 0 as the even natural number, we should not consider 0 then.
no, we should consider, but they should have mentioned here too, because in the question paper, see, whenever you get the question paper, in the instruction they will explicitly mention that consider 0 as a natural number. Okay.
Ma'am, in the last question, you
Hmm.
told me we have not learned that limit thing. So can you tell us the method if it is possible?
Actually,
That
it will take a lot of time. That's why, because in
so
that
after
also you have to consider some cases.
Ma'am,
After learning, you can guess that thing
ma'am,
yeah, you
easily.
can tell it
ma'am,
then.
only the LHL part only. For that, very RHL will be RHL is clear. LHL part, left hand
For
and
which
length.
one?
That particular question, under root 3 minus
That
x.
particular question. Yeah.
Left hand limit.
Left hand limit. See, okay, so you guys want so you whenever you have to ask the range, right? So
Hmm.
for range, we will find two limits. Okay, so one limit will be limit x going to, and suppose f is a function whose domain, it's also depend on the domain too. So whose domain is a comma b. Okay, here I am assuming that a and b can be infinity. Okay, so what you have to do, so you have to find, for finding the range, you have to find two limits. So first limit is limit extending to a of f of x, and the second limit is limit extending to b f of x. Okay, so in this case, what is our domain? So this is for those people who know the limits. So the domain is nothing but minus infinity to 0. Correct? So we are taking all the, not 0, minus infinity to 3. Right? We are taking all the values less than or equal to 3. So that means here we have to compute two limits. So one is limit extending to minus infinity of f of x. And another one is limit extending to 3 f of x. Okay. So if you compute this limit, so as x goes to minus infinity, we are getting positive values here. That's why this limit is nothing but infinity. And if you compute this limit, since under the root function is a continuous function, that's why this limit is nothing but under the root of 3 minus 3. We just substitute in terms of x, x is equals to 3, and the value will become 0. So that means here range will become 0 to infinity.
So here x
That's
is
how
tending to, x is approaching, as x is approaching 3, it the value of the function is getting 0.
correct.
And minus infinity, the value of x is approaching to infinity.
When x is approaching to minus infinity, f of x will approach to infinity.
Okay, ma'am, clear. Thank you very much.
Okay, so that's how you
So,
can compute the
so ma'am,
range.
for this method, we have to know the domain at
Domain we
at
have to
least
know.
one.
So after, there are several things you know, because you have to know, because see, this is a continuous function, so we can easily do such type of computation. Okay,
Okay,
if
and
it
if
is
it is
not a
not a
continuous
competition,
function,
okay.
then it's very tough to judge the rate. But in general, they will always give you a continuous function.
Okay, so if it's not a continuous function, this method can become tedious, like quite hectic.
Very tedious.
Okay.
Ma'am, just a little thing. How do we continuous and the one you are
These
talking
all
about?
things you will learn in the next few weeks. So in the 7th week, you will learn about the limit, and then continuity and differentiability. Okay, then you can easily apply
Okay,
this method.
ma'am, what is the easiest way to solve this question?
I'll
Ma'am
say
has
just
just
go via Desmos. That will be
Where?
the easiest. Desmos or by graph.
By graph. Can you explain once by graph?
I just did, right? This is the graph of this particular function. So
Acha,
here
acha.
you observe, as you increase the value, as you decrease, this function is growing to infinity, right? The value of y is growing repeatedly. Although it's growing with very small rate, but still growing. So here from this, you can say that, okay, we can approach any positive value of y. But we cannot find a value of x for which the value of y is negative. So that's why the range is 0 to infinity.
so ma'am, in the upcoming weeks,
Hmm.
shall we be able to find the range of a function which is not
See, the
continuous
range,
Ma'am,
through these
in
functions?
exam
Like,
we are not
no.
getting Desmos, right?
See, you're not getting the by Desmos.
Yes, in exam we are not getting Desmos.
Yeah, so then in exam we won't ask such type of complex function. See, this is also not a complex function. You just have to observe the nature of under the root function, right? So you know that f of x is under the root of 3 minus x, right? So this will be behave somewhere similar to under the root of x function. So as you take the much larger root, so for example, we know that under the root of 25, or I'll take 26, is less than under the root of 27. This much we know, right? So that means as you take negative values of x, you will get much higher values in the under the root. So
Okay.
you can observe that also, that f of x will go to infinity as you take much larger values. So that means you can actually attain every positive value of y, but you
If we
cannot get
go
the
to
negative
near
value.
positive,
Huh.
Hello,
So
ma'am.
you have to use some intuitions too. Yeah.
okay.
I'm a very term student. We have integral and limit, but I don't find any resources like in online. There are vast resources. So can I follow NCRT books?
Yeah, you
To
can follow NCRT. That's the best book, I'll say. For
Ma'am,
practice
as you
also.
said
And
that for the continuous, if the function is not continuous, we cannot do that limit thing. It would become very
huh.
complex. So in the coming weeks, you'll gonna teach those methods to find that range in 1 month, 2 months in the upcoming course.
After we
Maybe,
qualify.
but in general, yeah, but we don't actually deal with the non-continuous function
I think limit and
much.
continuity will be in second term.
Sixth, not in second term, in this term only, but in the second half of the course, sixth
Yes,
to
ma'am.
So, ma'am,
ninth.
you'll be teaching that how to find the
I'll
range with
teach.
the
Yeah, yeah,
of the non-continuous function with that limit
yeah, yeah.
process.
I'll teach some of the cases which are
Yes,
useful.
absolutely.
Okay,
Hello,
so
ma'am. Last
yeah,
question, 11. Because if I'm rationalizing it, so it's saying ki, the value I cannot take is -2.
yeah. See, so f of x is under the root of x plus 2, and this is x square minus 9 is there, so we can write it x plus 3 into x minus 3. Correct? Now here you don't have to rationalize it, because if you rationalize, then only it will become so if you rationalize this, then the things will.
Yeah, it, like
But
then the
still,
argument
still,
will not
still,
come.
still, huh. See, if you rationalize it, that means you are multiplying with x minus 2, correct? So x plus 2, x minus 2, and upon x plus 3, x minus 3 into x minus 2. But see, you don't have to rationalize it because it's not, we are not get rid of under the root of x plus 2. Right? Ultimately, I can cancel this factor and simplify my function.
Can you show it,
It's
ma'am?
already in its simplified way. Okay, so you are asking when you rationalize it, then you cannot take the value x is equals to 2, right?
Yeah.
That's your doubt, no? Huh. But see what happened. If you rationalize it and then take x is equals to 2, x is equals to 2, the f of x will become 0 by 0, which is nothing but 0. Right? The numerator is also becoming 0.
But the denominator can't be 0, right?
But we don't bother about denominator. The numerator is becoming 0, so 0 by 0 is 0 to us. But first of all, you don't have to rationalize it. But if you're rationalizing it, still your numerator is becoming 0. So I can say that it's nothing but 0.
Ma'am, but
Although
we cannot go to this condition 0 by 0 na. It is like just like
it's
iota.
already simplified. It's already simplified thing. So first thing is you don't have to rationalize it. And
Ma'am,
then after,
I think we have to rationalize only when in the denominator there is
in
under
the
root, like
denominator,
x
there is
plus 2.
under the root something. Then
Yeah,
only you rationalize.
and if
In this
it's in the
condition,
numerator, then we cannot do it like
because
it's
it's not giving something
simplified
new to us, right?
because
It's
it's
just
already
as it
simplified in
is.
the numerator.
Okay,
Hmm.
I got it. I got it. Thank you.
Okay.
Ma'am, can't we just make it the function equal to 0 and then find the value of the domain?
No. That's not how you have to find the domain. Domain means all those values of x for which this particular expression is well defined. So
Yes,
here are
ma'am.
two things. It's a rational function. So first thing we have to take care is denominator should not be equal to 0. Okay, so here you are saying that equal to 0 and then find the value of x, right?
Yes, ma'am.
So that means here, if you take x is equals to 3, then denominator will become 0. So that means we have to remove 3. It means for 3, the function is not defined, right? Not defined. And then second thing is this under the root function. So we want x plus 2 to be equal to greater than or equal to 0. Means x should be greater than or equal to minus 2. Okay. So that means x should be greater than or equal to minus 2 and x should not equal to 3. And x belongs to real number. So this will be our domain. Okay. Is that clear?
Yes, ma'am, clear.
Okay. Now let's go to
Ma'am, I have a
what's
doubt in the third question.
practice assignment third question.
Yes, ma'am. Yes, ma'am.
The
Yes, ma'am. So why is ACB
this
included?
one, na?
Yeah,
Mhm.
because ACB का जो है उसमें there's an intersection between AC and B, but like in the diagram it doesn't show as such like
There is intersection between
AC
A,
and B. Yeah,
AC and B.
Yeah, same doubt.
1, 5, and 25 will fall in A, B, and C.
Okay, so A is a set of all even natural numbers, including 0. Okay, B is a set of all odd. So there can't be intersection between A and B. That's pretty much clear, right? We
Yes,
have
ma'am.
even natural number and odd natural number. C with a set of all natural number which divide 100. So that means
Okay,
those
okay, ma'am.
natural
Sorry,
number which
sorry. I
divides
did not
100. So
see. Sorry, ma'am. I did not read the even natural numbers part. Sorry, it's my bad.
okay, fine.
Okay, ma'am. Got it.
Any other question from practice assignment?
But still,
Ma'am,
two
2.5.
A and C have
Activity
common.
2.5.
From in the
Yes,
third
ma'am.
question only, A and C has
Ma'am, just
common.
scroll because two
Wait,
options
one
are
by one.
same
Ma'am,
in
can you
this
please
question.
still help with the third question?
Yeah, third question is easy. See, A is discarded by B. I mean, A and B are
Yeah,
disjoint.
we get it.
And
A and B are different. But what about C?
so C is the numbers. C be the set of all natural number which divides 100. Okay. So suppose we have any natural number which is dividing 100. So what are the possibility
50,
for that natural number? You have to check, right? So n could
10,
be equal to 1,
20.
right? N could be equal to 2, n could be equal to 4, n could be equal to 5, n could
Hmm.
be equal to 10, right? Then n could be equal to 20, n could be equal to 25, n could be equal to 50, and then n could be equal to 100. These
Hmm.
are the only natural numbers. So here, these two are even, and there are some natural numbers which are odd. So that means C will intersect with A
5.
and B both, right?
Shouldn't we take 0 since it is said in the question including 0?
0, actually, something by 0 we don't. I mean, we don't generally divide by 0, because if you divide by 0, we will get numerous answer. That's why.
Oh,
So
yes.
the fourth option will be
Zero is
also correct,
infinity.
no?
Yes, yes, yes.
In the third question.
Fourth option is also correct.
Because,
Option is
but
correct,
it's
right?
showing that like it's wrong answer.
Oh, sorry,
D
sorry,
and
sorry,
C,
sorry.
how could?
Which is that D is what? A, B, C are intersected. D with a set of all prime numbers less than 100. So there are no even prime number. That's why D is disjoint from A. Okay.
So is that the way? Because C is intersects with A and C intersects with D. So in a Venn diagram, we can't show like if A and D are not similar in that way.
Okay, so let's draw the Venn
And
diagram
how
for this
D
one.
and C could be matched?
Ma'am, A and D will have an intersection too.
Yeah, 2 will be, huh? So A and D will have an intersection. D is what? The set of all prime numbers less than 100. So D will have a 2 which will intersect with A, and D will have 5 which will intersect with B, and C2. So that means D has intersection in B, C also. So but D will sit under C. So that means because D is what? All prime numbers less than, no, less than 100. I thought divide by 100. Okay, so let's go via option because they only contain 3 sets, so we don't have to draw. The first one is A and B are disjoint, but D is not inside D. D is not inside B. In D, we have 2, right? 2 belongs to D because 2 is a prime number less than 100. So that's why this option is not true, correct? Now the second option is correct because we know A intersection C intersection B can happen. Because for C, the
Here,
set of all
second
natural numbers.
option. What is the extra in C which is not there in A and B?
What
Because
are the extra C? The set of numbers, natural number, which are divisible by 100. Yeah, there won't be extra, but okay, we can. There won't be any extra C because obviously these two numbers will form the whole natural
but the
numbers.
figure shows there is something extra
There
other
is
than A and B,
something
no?
extra.
So how
But
is this becoming correct answer?
yeah, but you can generally say that okay, some intersection is there, but obviously then how they should have drawn something like this then. But it's okay. I mean, not that much valid, but still,
That's okay. The option is okay.
not that much specific,
No,
but
no,
it's
B
okay.
is the
No,
set
no.
of all odd natural numbers. Let's suppose there is a case 33.
So then 33 all natural number divides 100.
comes under B because it's an odd
But
natural number, right? And it is not part of A, it is not part of
But he says that C should have been inside of A and B, union of A and B. That's his doubt. And that's correct, although. Hello? Yeah, his doubt is correct because see, what is A? A is all even natural number and B is all odd natural number. So if you union them, you'll get all natural numbers again. So any natural number, any set will be inside that particular union, but that's okay. We don't need to be that precise. Okay. Third option is D and C are intersecting, and that's also correct because C is the set of natural number which divides 100, and D with a set of all prime numbers less than 100. So we have 5 in this intersection, and 2 is also there. Please mute yourself.
Ma'am?
Yes, ma'am.
Yeah, ma'am, activity 1.10, question number 6.
Yeah, I'll go to that too after discussing this one. Okay, so I think this question is okay.
Oh, what about the fourth option?
So fourth option, A intersection C intersection D is there, right? C and D are intersecting because 5 is in C and 5 is also in D. And A and C are intersecting because 2 is in A and 2 is in C. That's why. 2 is a even number and 2 is also a number which divides 100.
So
Correct?
it would be a right answer.
2 is also a prime number. I think that is
2 is
why it is
also
not
prime
valid.
number.
That is not
Okay,
valid.
okay.
They also intersected.
So that's why.
Okay, so that means
That's
A
why.
and D is also intersecting. That's why it's not valid.
Yes.
Yeah.
Ma'am, there's the number 2 which also includes in the set A and also includes in the set
in
D.
the set D.
And that's why that set is not possible.
Yeah, fine. Any other question from this one?
Ma'am, 2.5.
2.5?
Yes, ma'am. Activity 2.5.
No, I will just discuss doubts from week 1.
Okay, ma'am.
Okay. The next session we'll go.
Ma'am, can you
please
just
again
explain me about
explain?
squared sum error?
That will take at least 15 to 20 minutes. Okay.
Damn.
So actually it will take 15 to 20 minutes.
Madam, again, I'm sorry, madam, but option 2 should be wrong. See, I don't want to assume anything.
I know what you are saying because obviously if set of all even number and set of all odd numbers, if you collect them, it will form the whole natural numbers, right? So
Yes,
every
madam.
other set should be inside there, but they
Yes,
have
madam.
drawn something like that only.
No, that's correct. Let them draw, madam, but they should mark it as wrong. How can they give it as right?
As right. Yeah, there is some precision is not there.
Yeah. Then you have to correct it, madam.
I'll correct it. I'll mark
Sure,
it down.
madam.
What that
Thank you, madam.
question number is? I'll check.
Ma'am, can you again please explain the second question from practice assignment just a little bit? I'm not getting something.
Okay, so
It says let this second
let A be
question
the
is
set of natural number less than 6 and whose GCD greatest common
with
divisor
6
with
is 1.
6 is 1. Set of natural number less than 6 and whose GCD with okay, so let B be the set of divisors of 6. So what here you can do, so A is set of natural number less than 6. So we have 1 to 5 whose GCD with 6 is equals to 1. So that means 1 is there, 2 won't be there.
Ma'am, should 0 be not considered as one of the elements?
See, divisors we are talking. So in general, divisors I don't treat 0 as a divisor of any number.
Yes,
Because if you divide 6 by
0 doesn't
0,
divide anyone. Yes, that's
so
I thought. Okay, ma'am, that's right.
right.
I included 0. Yeah, ma'am, that was my mistake. Otherwise, it's all correct. Okay, ma'am. Thanks.
Okay, now let's go to 1.11.
Ma'am, how could be the slope of a line which is parallel to y-axis is not defined?
Because what is the expression of slope? Slope expression is y2 minus y1 upon x2 minus x1. So for any line which is parallel to y-axis, we in the denominator we are getting 0, right?
But
so
ma'am,
same
it can be
problem is
plot,
there.
na? But it can be
It
plot
can be
with
plot. Yeah, obviously it can be plot, but that doesn't mean that the slope is well defined. Slope means change in x with respect to change in y.
Yes,
right?
ma'am.
Sorry, I said opposite. I mean
Del
change in
y
y
by
with
del
respect to
x.
change in x. So here x is not changing, so that's why. Okay.
Ma'am, for that, ma'am, the line parallel to x-axis also have a slope not defined.
No. Line parallel to x-axis has slope defined because that is a
0.
function, right? And that slope is 0. So
And
slope of that line is well defined. We have already discussed these things, horizontal lines, vertical lines in detail
and
in the lecture.
moreover, professor is very clearly has explained that, madam, in the lecture.
Yeah.
People would have watched it.
Okay. So now let's get back here. So which question you guys are facing any trouble? You can mention that and we can discuss.
Ma'am, question number
So or
7.
else
So I
question
want,
number 7.
sorry, I want to know a method how to find max and min for any function.
For that you need to learn derivatives. So for now we don't have knowledge about derivatives. So let's leave it. Now, if I want to explain derivative, then it will take very, for that you have to know limit and then continuity and then differentiability. Okay. So this is the question. Na? Question number 6. Na? So if f of x is equals to under the root of this thing, then the domain of function f is. Okay. So as I told you, for finding domain, you have to find out those values of x of real number for which this is not well-defined thing. Okay. So here what is happening? Under the root of 14 minus 3x plus something is given to us. So for under the root function, we want inside expression to be greater than equal to 0. Right. So it means 14 minus of 3x plus 35 minus of 5x by 4, this should be greater than equal to 0. Okay, so that means it simply says that 14 should be greater than equal to 3x plus 35 minus 5x by 4. Okay, and if you just solve it, what I'll get, so it will be greater than equal to 12x, and I'll just multiply it by 4 here. So this will be 56, and this will be 12x plus 35 minus 5x. Okay, so this will imply that 56 should be greater than equal to 12 minus 5, that will be our 7x plus 35x, and I can take 35 over here, so this will be 21, should be greater than equal to 7x. So that means
X should be
3 is x should be less than equal to 3.
yes,
So
sir.
that means the domain will be minus infinity to
Minus infinity to 3.
close 3, because for 3 it is well defined. Okay, is that clear?
Yes.
Any doubt? Okay. Okay, so any other doubt from this activity group?
Ma'am,
1 to
question number
until 11?
7. Question number 7.
Okay, you asked 6 or 7? I thought you asked 6.
Ma'am, 7.
Okay, fine. So the domain and the range of the function is shown figure below is mx, y. Okay. So what will be the value of mn n respectively? So see, whenever a graph is given to you, so first of all, find out those points where the graph starts and ends and mark those points. Okay. So over the horizontal plane, so if you consider this way, this is the last point on x-axis where the graph starts, or we can say this is the last point the graph will mark over x-axis, right? And these are the two last points the graph will mark. So that means if you draw a rectangle here, the graph will lie inside this particular rectangle. Okay, this particular rectangle. So what you have to do, you just have to find out those values of x and y. Okay, so here the x value is minus 4 because the coordinate is minus 4 comma 2. Here the x value is 9 because the coordinate of this point is 9 comma 6. Here the y value is explicitly given 9 because the coordinate of this point is 0 comma 9. And here the y value is equal to 1 because the coordinate of this point is 3 comma 1. Right. So the first one will be x coordinate. X coordinate means distance travel in the x-axis, and the second one will be y coordinate, distance traveled over the y-axis. So here the least value is taken by the function is 1 and the greatest value is taken by the function is 9. So from this I can say that any value between this 1 and 9 can be taken by the function, correct? Because if you draw a line here, then this
Yes,
line
ma'am.
will intersect the graph. So that means there are points, input points for which we have a output value. So that's why the range will be 1 to 9. Okay, and the domain will be those values of x for which we are getting out. So in between x is equals to minus 4 to x is equals to 9, for every point we are getting output. So that's why the domain will be minus 4 to 9. So we can interpret what are the values of m and n. Is that okay? Neetu, I guess.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am. Clear, ma'am.
Okay, so I'll check the YouTube link, whatever provided there. Any other doubt from this activity 1.11?
Hello, ma'am.
Ma'am,
Yeah.
number 2.
Ma'am, whenever we solve the type of inequation which is greater than equal to 0 or less than equal to 0, so in that type of case, whenever we multiply or divide both sides, should we need to change the sign like you
No,
did in the
whenever
previous one?
no. When you multiply by minus when you multiply by minus, then only you have to reverse it. When you divide, you don't have to reverse the sign.
Okay, ma'am. So in the case of multiplying by any negative number, we should only then change the sign of that greater than
Multiplying by
equal to or
negative
whatever it
number.
is.
Right.
Okay, ma'am. Thank you.
Yeah. So the second question says the product of minimum value of the function and the maximum. So here also you have to use Desmos. See, this thing you cannot find minimum value and maximum value of this function by. I mean, you can find. It's a modulus function only. So this is f of x is equals to 9 modulus of x minus 8, and g of x is equals to 11 minus modulus of x plus 8. So what you can do, you can just draw the function. You will use Desmos and then you will answer. Okay.
Ma'am, but without Desmos also we can do it by hit and trial actually.
Okay, by hit and trial you can do. Yeah, I think so you can do. Although
Because
we can.
in the mod function by hit and trial it's more easier if they are finding they are saying about the range. Yes.
Right. So what we can do, we can just try to substitute some of the values. So here, so see f of x is equals to 0. I think on 0 it will have a minimum value maybe. So 9 modulus of x minus 8 is there. So f of 0 is 9 minus is simply minus 8, right?
Yes,
And if
ma'am.
I put f of 1, so f of 1 will be 9 minus 8, which is equal to 1. F of minus 1 will be also same, right? 1 is only there. What is f of 2? F of 2 will be 9 multiplied by 2 minus 8. So we will get a bigger value there, right? So minimum value will be minus 8 only, correct? So minimum value will be minus 8. And for this function, the minimum value will occur at when x is equals to minus 8.
Ma'am,
Right?
here
Because
they are
then it
asking
will
the
become 0.
maximum value actually.
Okay, sorry. Right. So the maximum value we have to take, so that also occur at minus 8 because we have to do 11 minus something, right? So 11 minus something bigger than 11 will give us a negative value, negative quantity, right? So that means 11 minus of 12 if I do, then I'll get minus 1, right? So I want to find out a value for which this particular modulus will become 0. So I can do x is equals to minus 8. If you substitute x is equals to minus 8, you will get 11 minus modulus of minus 8 plus 8.
So ma'am,
Which is
actually
equal to
when
11.
we have to make it maximum, we have to minimize x plus 8. And when we can able to minimize x plus 8 is x should be equal to like 0
Minus
only.
8. Minus 8. This is minus 8. Okay, so the maximum value will be 11. Here the minimum value will be minus 8. And what is the product will be, what's that, 11 multiplied by minus
Minus
8.
88.
8. Okay. Yeah, by intuition also you can do. It's an easy question, I thought. Okay, any other question from this activity? Okay, now let's move to another activity. 1.10.
Ma'am, question number 6.
1.10?
Ma'am, question number 6.
Of this activity, na 1.10.
Yes, ma'am.
So suppose the relation R is defined on a set. So the relation R on a set S is reflexive. Okay, so Purnima, what's your answer here? So what is the answer you have got for this particular question? Okay, so let's answer for reflexivity. So is this relation reflexive?
No, ma'am. Every element is not related to their
Correct. So Purnima, did you got the answer? Reflexivity is clear?
Yes, ma'am.
Okay. What about symmetricity? Is it symmetric?
No, ma'am.
Purnima, can you tell? Is it symmetric?
No, ma'am.
Because see, snail and frog, this pair is there, but it's symmetric pair, which is frog and snail, is not there in our R, right? It's not an element of R. So it means the symmetric pair is not there for at least one pair, which will tell us that it is also not symmetric, not reflexive, not symmetric. What about transitivity? Is this relation is transitive? So let's find out the
Ma'am, it
transitive
is
pair are there
transitive.
or not.
It is transitive, ma'am. Because
Transitive, right?
when we take the last two,
Snail and
snail,
frog.
fox, and
Snail
fox
and
and
fox. Fox and frog is there. So we have one transitive pair, which is snail and fox, and the another one is fox and frog. So its transitive pair will be snail and frog. So we have to check snail and frog is there or not. But snail and frog is there in our relation. So that means it's true. And we don't have any other transitive pair to check. So that's why this will be a transitive relation.
like if it's स्नेक फ्रॉग की जगह अगर फ्रॉग और स्नेल होता तो ट्रांजिटिव नहीं होता ना ये लाइक फर्स्ट ऑप्शन
नहीं
जो है
नहीं, फिर वो पेयर दूसरा
frog।
बन जाता, फिर
हाँ वो पेयर
फॉक्स
दूसरा बन
एंड
जाता।
फ्रॉग बन जाता है ना। Okay,
नहीं
any
मैम
other question?
व्हाट आई वाज सेइंग लाइक स्नेल और फ्रॉग है, अगर फ्रॉग और स्नेल होता तो अलग रहता है ना
अच्छा,
मैम
हाँ
इसमें।
हाँ 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 हाँ, तो भी अलग हो जाता। तो फिर अगला पेयर फिर फ्रॉग और फॉक्स चाहिए होता है, वो नहीं है हमारे पास, फॉक्स और फ्रॉग है ना ट्रांजिटिव पेयर।
Ma'am, how it is transitive? Can you please explain it again?
So see, here what happened in transitive relation, there are two conditions. Either if we don't have any pairs, so like this a b comma b c, right, then we don't have to check the transitivity. But here we have one pair like this, which is snail and frog and snail and fox. So you can consider this to be your a comma b. No, sorry. Yeah. Yeah, right. So you can consider not this one. We have two pairs here. So we have snail and fox, and we have fox and frog. So you can consider this to be your a comma b, this to be your b comma c, right? Because fox is there, we are considering b to be fox. So we have one transitive pair a comma b and b comma c. So we have to check a comma c is there or not. So a comma c will become your snail and frog, but snail and frog is there in our relationship. So that means satisfying the definition of transitivity. That's why it is a transitive relation. Is that clear?
Yes, ma'am.
Okay. Any other doubt from this activity question? Activity we are 1.10.
Ma'am, what if
Question
we
number
take,
one. Question number
ma'am,
one,
what if
please.
we take
Number
snail
7.
and frog A and B and bird and that C and D?
Yeah, it can be, see, you can make example as much you want. Okay. So
Ma'am,
question
but if
number one.
other one no. So what if
It
they
depend on
didn't
the question,
match?
no? Then you have to check for every pair. See, you can, you have the definition, just make the example. So here, what's your doubt? Suppose A is belong natural less than 10. Which are the following is subset of A cross B. So you can consider A and B, what are those? Okay, so A is all natural number which are strictly less than 10 and odd. So simply we can say that A is 1 because 1 is odd natural number less than 10. 2 is not there, 3 will be there, 5 will be there, 7 will be there, 9 will be there. Okay, this will be our 1. And the B says natural number perfect square between 15 and 14. So you have to consider the three things too. Okay, so first of all, perfect square. So what are the perfect square means? Those number whose square root will again become a natural number. So from 15 to 14, we have 16, which is a perfect square. We have 25, which is a perfect square, right? We have 36, which is a perfect square. That's all, right? These three numbers are only those natural numbers which are perfect square and lying between 15 and 14. So this will be our B. 16, 25, 36. Now we can compute the Cartesian product. So the answer should be this one maybe. 1, 5, 3, 9, 7 is there. 16, 16, 36, 36, 25. One more pair is miss. No, fine.
No, it's
They are
B.
asking for subset only, madam.
Which of the following? Oh, subset. Fine, fine. Now then you can answer. Once you figure out A and B, then you can easily answer for all the questions. Right? Is that clear?
I was confused about this 15 and Y and 40.
Okay. So see why between 15 and 14. So you don't have to consider 15. You don't have to consider 42. 40 is a perfect square, but you don't have to consider 40 because
No,
strict inequality
40
is there.
also is not a perfect square, madam. 15 and 40 are not perfect squares.
Oh, sorry. Yeah, there should be one more zero. For 40, I thought 20 not 20 square is 400, not 40. Fine.
Question number 7, I have a doubt.
Okay, so what's your doubt here?
No, I can't solve it, this sum.
Okay, so let P be a subset of S cross S minus R. What is the set of possible cardinality of P? What is S here? S is we have 4 element for S. So if you compute S cross S, that will be our 4 by 4. That means 16 elements will be there, right? So since cardinality of S is 4, cardinality of S cross S will be 16. Right, 4 multiplied by 4, and then we have to remove R. So that means from S cross S we have to remove 1, 2, 3, and 4 pairs. So that means you have to remove 4 pairs, 4 elements from S cross S to find out the cardinality of S cross S minus R. Okay, so the answer will be 16 minus 4. That will be equal to S
12.
cross. So what is the
12.
possible cardinality? Okay, so we can easily find out the exact cardinality, that is 12. But possible,
It's
okay, they
subset.
have
Subset.
again subset. So okay, so the cardinality could be 0 to 12. Okay, so I have to do, I mean, there are so many activities now, that's why. Okay, but the concept is clear how you can find out. So see, since the original set's cardinality is
Ma'am,
12.
why we are taking 0 as a set
0 for
possible?
empty set, right? Every empty set is a subset of every set. Is a subset of every set, right? And this set will have cardinality 0. That's why we are taking 0 too. Is that okay?
Yes, ma'am.
I hope. Any other question
And ma'am,
from this activity?
in this question, the relation R on the set R is R. What will be the answer of this question number 6?
The relation on the set, it is transitive, right? We just solve this one. It is a transitive relation.
Okay, ma'am.
Okay. Fine. Any question? Any other question? Okay, let's go to 1.9. So from this assignment, do you have any doubt? The last one maybe, but yeah, you guys can figure it out. Just the equation of lines. No. Okay. So I have explained function in last 2 sessions. So Pankaj, you can just go and check that. We have done so many examples about function, vertical line test and so on. Yes, Purnima, any doubt?
Number 6, ma'am.
Number 6. Yeah, that's what I was thinking. So suppose f is from z to z is a function defined by f of x is equals to ax plus b. For which of the following integer value of a and b, the given function is bijective. So you'll check one by one all options. Okay. So now suppose a is equals to 0. So if you put a is equals to 0, then your function will become simply b, which is a constant function. And we know that constant function are not 1, 1. So if a function is not 1, 1, we'll simply imply it's not bijective. Correct? So that's why this option is incorrect when we take a is equals to 0. Now the second option gives us two values, a is equals to minus 1 and a is equals to 1. So let's consider a is equals to minus 1 first. So if you consider a is equals to minus 1, f of x will become minus of x plus b. Okay. Now for b, we have all choices that for b, you can take any integer value. But here, what is this? This is nothing but a equation, which equation of a line, right? It is nothing but equation of line for any integer value of b, for any b. So it means no matter whatever b you will take, it will always be a bijective function, because we know that line is nothing but a bijective function. The equation of line or the graph of line will something like look like this, and it's a bijective function. So that's why this option is correct. The third option is also not correct, because a is equals to 0 thing is there. Whenever a is equals to 0 means it will become a constant function, and again constant functions are not 1 1, not bijective. So it's also not correct. Can you just the last one, last option? Is it correct or not?
It also incorrect, ma'am.
Okay, and why is this? Why is that? Because here also we can find a is equals to 0, right? A belongs to integer, that means A is they should have written belongs to here. A we can take from this set Z, where Z belongs to integers, right? So that means A can be 0 here. That's why this option is also incorrect. Okay,
Ma'am,
because
if
if
A
A is equals
become
to 0, yeah.
yes, ma'am, please continue what you were saying. I'll continue after that.
So see, if A becomes 0, then it's nothing but just a constant function. And we know that constant functions are not bijective functions.
Madam, fifth question, first option, can you explain, madam?
Yeah. This question is clear, right?
Yes,
Can
yes,
we say
madam.
that is a bijective function?
Sorry, what?
The line, um, the line represent you
A
told me.
bijective function. Yeah, so yeah, any line is 1, 1 and onto function. You can just see the graph. By the graph, it will satisfy the horizontal line test. So that's why 1, 1. And if you find the range of a line, then it will go to infinity and minus infinity both sides. So that's why it's bijective function. Okay. So first option, na? So let x belongs to R. The domain of f is this. Which of the following function is injective? Okay. So it is an injective function because it satisfies the horizontal line test. If you know the graph, that's okay. And if you don't know the graph, you can easily prove it too. So how you will prove? So we'll use this particular definition of 1, 1 function. Injective means 1, 1, right? That x1 equals to x2 will imply f of x1 is equals to f of x2. Right? So x1 is equals to x2. So let's assume let's say x1 is equals to x2. So if these two quantities are equal, their minus of x1 is equal to minus of x2. Correct? And if these two are equal, that means if you add 10 in these two things, that's also equal. Okay. And if these two are equal, their under the root will also equal. So which will implies f of x1 is equals to f of x2. So we have proved that it is a injective function. Is that clear, Narendra?
Okay, madam.
Yes,
Yeah.
ma'am, but what about the other options?
So this one also you can prove that it is a bijective function. And this one is nothing but just an equation line. So it is also a bijective function. This one you can prove by the similar method. Just assume x1 is equals to x2 and go by the same steps. You will get f of x1 is equals to f of x2. This one
Okay.
is not a bijective function because ultimately it will become a quadratic function.
So, ma'am,
Okay.
basically, every
Basically,
quadratic function cannot be a injective function, so it
cannot
cannot be
be
a bijective
injective.
function. But
Right,
for
right,
the
right.
cubic thing, it can be.
Uh,
It can be. There
Cubic thing
may
it
be a
can
condition.
be because x cube is a bijective function. F of x is equals to
So we
x
have
cube.
to check for the cube. Like it can be or it
Hmm.
cannot be bijective or injective.
Yeah,
We cannot say that.
correct.
So
Right.
for the degree of x, if it is even, like
Then,
like quadratic, it's not injective. If the
it's
degree is
not
even, it's
injective. Yeah,
always
correct. Correct. It's always the
not
case because
not even an exception is there if the degree is 4 or something like that.
no, there is no exception. Because if you consider any polynomial with even degree, it won't be bijective. Because what happened when we have even degree, na, then from the both ends, that means for both sides, so for infinity and for minus infinity, for both sides, either function will grow toward the plus infinity side or function will grow toward the minus infinity side. So in both cases, there will be one line which intersect the graph more than one point. Okay. So whenever you see an expression involving the even degree of x, the largest degree of x should be even. Okay, that means x square x cube x square x to the power 4 x to the power 6, that type of thing. Then it's not a bijective
Because the
function.
root will be plus minus x. So plus
That's
minus
why
x cannot be, it cannot be
there
symmetrical.
will be one square type of thing.
Okay.
Okay.
And for the constant function, it is always like that. Like in the second option, the
Because
constant has to
constant
be.
function and will always give us the same output for any input. That's why it
Suppose, ma'am, in
never
the
become
numerator there is constant, and in the denominator, suppose in this question, the second option, 3x plus like 4, in the denominator is 3x plus 4. Then
then
this
also
is
it will become bijective, I guess. I think so. But
okay.
you have to check via the definition also. I'm not. Yeah, I think it will become bijective. As I.
If the numerator and the denominator both having the x is equal to 1, like the degree is 1, so it's bijective by default.
It will become. It will become bijective. You can check it too.
Okay, okay.
Okay. Any other doubt from
Applying
this
the
activity?
same rule in question 3, so it's a quadratic function. That's why it is not bijective. So
Quadratic also, and modulus is also there. So modulus means for any negative and positive, if you take the value of x to be minus and plus, or some same quantity, suppose -1 + 1 type of thing, you'll get same answer. So modulus is also there, that's why also, and it will become a quadratic too, that's why also. Okay, so you will learn why the quadratic function are not bijective in the next week. There we have parabolas and all quadratic functions only. So there you can easily learn why these are not bijective.
the modulus part I did not get. Can you tell me once again?
Yeah, so modulus means, so suppose this is so suppose I'll take any value of x is equals to suppose I'll take 5. Okay, so 5 is okay. So x is equals to 5 if I take, then maybe x is equals to 5 won't work. I mean, you will find out some value of x. Okay, some
You can
value of
take
x.
less than 5, I mean, 4 times x now, madam, like 2.5, less than
Ma'am,
2.5
you
you want to take.
20.
Less than 2.5 or 2
So
if you can take.
let's
ma'am,
take
you can
0.
just take a
Like
simple
0 is plus and
example like
minus.
modulus x minus 4. So
That
for
also
one
you can
value
take.
of x
Simply you can take alpha of x to be modulus of x, right? So here some
or
expression
x
is
minus
there.
4 also in modulus.
Okay, x minus 4, let's take. Then for what happened? So we want same input, right? So let's take x to be equal to 5. Then f of 5 is 5 minus 4, but we are not getting the same output. So modulus of x minus 4 is there. So this is modulus of x minus 4. So we have to take some large value maybe. So
Ma'am,
put
we can
x
turn
is
this to
equals to,
quadratic equation, right?
sorry, what?
We can turn this into quadratic equation, right?
Madam, you can take 5, 1 point is 5, so it will become 5 minus 4 is 1. Another is,
Yeah, but
yeah,
we for 1 we need x1 is equals to x2, but sorry, what I was thinking, as I was thinking opposite. Yeah, we can take x is equals to 5, and f of
1 more
5
x
is
equal
got it. So this
4,
is
5
equal to
minus 1
1.
is 1.
So x is equals to 5 I can take, and then x is equals
3.
to 3 I can take. Right.
So you'll
So
get
f
minus
of
1,
3,
modulus minus 1 is 1.
right? Modulus minus 1 is 1. I was thinking I need x1 is equals to x2. So same thing you can do here too. So you'll take x is equals to something, get some value, and then take some other value of x. For that you will also get the same value. Okay.
Ma'am, I wanted to ask that if you draw a circle, the equation of a circle is it a function?
It's not a
Is circle a
function.
function?
No, it's not, because it failed the vertical line
Vertical,
test.
Okay,
vertical
ma'am.
line
Okay.
test.
Okay, ma'am.
Okay. Okay, so let's go to the next activity, 1.5. Okay, so any doubt in this activity? Activity 1.5. No, then we can move to 1.4.
Madam, I'm sorry that we were talking about surjective and like modulus one. Can you go back to that question, ma'am? Please. Yeah,
It will be
1.6.
activity 1.6 now.
Yeah. In this question, um, no,
1.5, I
sorry.
guess.
In this question, the 1.7.
Where is that question? 1.7 maybe. Example set operations. Still we don't have. Yeah, just explain what's I remember the
Yeah,
question.
where is the codomain defined, madam, in that question? For
Codomain
subjective,
depends.
why we have told that it is not subjective actually in that question?
So see, if in general codomain is not given to you, we assume that function is from real number to real number.
Correct, madam. So negative
That's why.
numbers you will not get range.
Because of the modulus thing.
Yeah, modulus negative will not be in the range. So that's why it is not subjective. Okay, madam.
Subjective.
Okay. Thank you very much, ma'am.
Okay, let's go to 1.4. Any doubt in 1.4, activity 1.4? This is previous terms activity question. Okay. Any doubt in this activity?
The three lectures are almost everybody understood, madam. It was easier said.
Yeah. Someone has activity 1.2 doubt, I guess. 3 questions are only there. Okay, so that's all. Any questions which is not clear, and if you guys have still doubts, then I can discuss that, or else we can discuss
Ma'am, in this
some
question
other.
number 2, the reduced form is like in this
Reduced
question
form
number 2.
means there should not be any common divisor between P and Q.
Okay.
So if right, P by Q is there, then there should not be any common divisor. That means you cannot simplify it and write it down. So
Okay,
for
ma'am.
example, 12 by 27, you can divide it both numbers by 3, right?
Okay.
Now, if you have any doubt, you can just any question which you want to ask, just send the screenshot and we can discuss it.
Maybe today is the first time we are going to finish this session before time, madam.
I also thought it won't be finished before time.
Hello.
Yes, Pawan.
I have a doubt in 1.6 activity question number 5.
See, we won't finish it in time. 1.6.
Question number 5.
So which of the following intervals are subset of 2, 3? Right? We have done this question in lecture, I guess. Let's see. So see, whenever such kind of question is there, it's better to judge this by, I always do with the real line concept. So this is your real line. So in which option you have doubt, Pawan?
Question number 5.
Yeah, but which option? There are 4 options, right?
Option number second, I thought. Second.
Okay, so see, in the second, first we will solve this bracket. So this bracket involves 2 intervals, which is open 2 to close 2.5. Right? So I am writing this interval in terms of real line. So in real line, over the right hand side, we will take positive number, over the left hand side, negative numbers, right? So and the second interval is open 2.5. So that means open 2.5 to close 4. And if you compute the union of these two intervals, you will get open 2 to close 4, right? Because 2.5 point is involved in this interval, so it will come in the union, right? So this is the union part. Now what we have to do, we have to minus this particular interval, which is 0 to, so here somewhere 0 is there, and then 2.3 is there. So we have to remove this interval. So when we remove it, what we get, we have to remove this one. So that means we have to remove up to 2.3, but not the point 2.3, because 2.3 is not there in this open interval. So we will get close 2.3 to close 4. Okay, so this will be our this particular interval, and it is not a subset of close interval 2 to 3, because we are going up to 4. There are so many points after 3 we are covering, so that's why it's not a subset of this particular interval. Is that clear, Pawan?
Then it should be a subset of 2 and 3.
We are going up to 4, right? So subset means what? So if if B is a subset of A, so that means every point of B should be in A. But here I have a point 3.5, right? 3.5 belongs to close interval 2.3, 4. But 3.5 does not belongs to close interval 2.
Okay.
Right?
Got it, ma'am.
So that's why it won't be a subset.
Got it.
Any other doubt from any other question? Okay, so learn these concept, relations, functions, and all those things very well, because once you pass week 1 and week 2, once you've gone through the qualifier, you won't get any time in quiz 2 to revise these concepts. Okay, so make your foundation very, very solid so that you won't have to go back to these relations and functions every time. Okay, because in week 2 and NTEM, you won't get any time to revise these concepts, I'll tell you, because there the concepts are tough, and more than that the time is very less, so that's why. So complete this week 4, I mean, as good as you can. Okay. Any other thing, any other topic you want to discuss?
Thank you very much, madam. The session was really
Activity
good.
1.6, question number 1.
Okay. Yeah. Question number 1. Which of the following sets are infinity? Is that the question? Someone asked the doubt, na? Activity 1.6, question number 1.
Yes, please.
Yes, Shweta. So here the set of Indian Nobel literatures, right? So there are not infinitely many. There will be finitely many only, because Nobel Prize will start from certain timeline. So it will be in the 80s or yeah, I guess in the 80s or in the 90s, something like that. But there will be only finitely many. There won't be infinitely many, right?
Ma'am, there will be infinite, na, because till the human civilization that will going to last, it will
No,
going
no,
to
no.
last.
Nobel Prize will start it from certain fixed timeline, right?
Yes,
There
ma'am,
will
from
be
the fixed
first
timeline, but it will go
to
till the
now.
human civilization will be there, na. So it will be
No,
thousand
no,
and
no,
thousand of years.
no. We don't know about the future, right? It is a possible that no one get the Nobel Prize in the future, right? So we don't know few about the future. We know set of all Indian Nobel literatures. So it means whatever Indian Nobel literatures are there so far. Okay, so there will be only finitely many. You're getting my point? You can list it
Okay,
out.
okay.
There will be either lakhs or
They should
thousands
have
or
mentioned
crores.
it, na, like till this time only, because
Okay. Now set of square of all odd natural numbers. So odd natural numbers are infinite. So their squares will be infinite. So that's why this will be an infinite set. Set of all countries in the world. Again, it's a finite number, 160 or 150 or whatever this is. Set of all leap year. This is an infinite set because we know that there will be infinitely many leap year. You can just multiply it by 4 and whatever. So 2020, then 2024 and 2028 and so on. So there will be infinitely many leap years. Is that okay?
Madam, third option you have to untick.
Yeah, sorry. There are finitely many countries.
Okay, thank you.
Okay. Okay, so I have uploaded the notes of last 2 lectures in the calendar link. So there I have uploaded one drive link. So just save that drive link. I'll upload every lectures, I mean every session's notes in that particular drive link only. Okay, and if you won't save it, I'll always paste it over the every session's description. So you can go to the calendar and then check the link. Okay.
Okay,
So if
thank
you
you.
have, yeah, thank you guys for joining. If you have any
Ma'am,
doubt,
there
we
is
can discuss
one
this.
thing for the next session after the qualifying exam. If somebody is going to take it in December, so those links will be available in the calendar.
Those links will be available in the calendar.
Because
And
after the
as
qualifier
some,
exam, the person is
Mhm.
taking the course in November, December. So,
Nah, copy piu ka.
so ma'am, those links will be
December.
available for that person after the qualifier if he's going to start in
Yeah,
December
yeah,
batch.
yeah, those links will be available. You can also find out links for the last term's live session too in the YouTube over the YouTube. Okay.
Ma'am,
How?
where can I find the current and upcoming subjects of math?
Sorry, what?
Suppose I want to find out which subjects I am going to read next week in math, or suppose next week or week after that, a total subjects or syllabus of math. How can you find it?
The for maths 1 syllabus, you can find the syllabus in the either in the
Not
important
only
links.
maths, I mean not only maths, total maths for
Okay,
this course.
overall the courses,
You
over
can go in the
the
dashboard and see the syllabus of in IIT Madras. You will see whatever it will going to teach. They have the videos and everything.
And
There
second
is a
thing is
possible
YouTube,
anything also
IITM, YouTube Max, all lectures are already uploaded, posted there,
recorded.
recorded.
Ma'am, but
Already posted.
suppose if somebody is going to take the lecture like for the next session after the qualify exam, he's going to take it in the December session. So you
The
said
session.
in the YouTube, yeah, in the December session, he wants it to start off. after the
December,
qualifying
right?
exam.
Why
Next
December? We
next
are
session.
already in January.
No, if somebody wants it to start from December after
December
qualifying exam,
25, 2025.
yeah, after the qualifying exam. So, ma'am, you said the link are already available on YouTube,
Link
but
will be always there over the YouTube. You can
ma'am,
anytime you can go and check.
okay, in the same YouTube channel because we have to filter it through because there are a lot of links of the previous session also, last session also,
Hmm.
and this session also. So they delete the links of the last sessions or how it is
No.
function.
I think they will use just go to YouTube and you can save that playlist into your YouTube, right? So if the links are not working, the direct links are not working, and you can just go and save that playlist in your YouTube
So the
playlist.
playlist of this session also is there and the last session is
Ha.
also there.
Yeah,
Okay.
right. Last term sessions are also there in the playlist. Recorded sessions, live sessions are also there. So you can just
Okay,
go
okay,
and save
okay.
that
So the
particular
list
playlist.
is still like after the foundation, after the qualifier, and this third year,
Hmm.
fourth year also.
Yeah, it will always be there on YouTube.
Okay.
Okay.
Okay, madam. Thank you very much for the session. It was a really good session. Good night.
Yeah. Thank you.
Thank you
Good
so much,
night.
ma'am. It was very good session.
Thank you guys. Bye. Good night.